Okay, so hi everyone. Thank you for attending to this session, and welcome to the Salt or Ansible session at SaltConf 18. That's not a typo, okay? So my name is Pablo Suarez. I'm senior software engineer at SUSE. I'm part of the SUSE manager team, and also now part of the new Salt team, Salt squad that we have at SUSE. Let me ask you some questions. So how many of you have used Ansible? Oh, nice, ton. And how many of you have heard that Ansible is easier to start with than Salt? Okay. And how many of you have tried to migrate a customer from Ansible to Salt? Okay, so during this session, I will show you how Salt is competing with Ansible and how SUSE is contributing to Salt to make it even better, easier, and saltiest. Okay, so let's start from the beginning. We are SUSE. Where are we? We have been, well, we are a SUSE Linux, a Linux enterprise distribution. We have been there doing enterprise for 25 years now, and our distributions run in supercomputers. We are making also that the airplanes to fly in Germany with zero downtime. Why we
except when they land.
And why are we here? So we have adopted at SUSE Salt as a core component in few of our enterprise products, and we are now deeply involved in the Salt development. So why you want it? So we are here for you. We are improving Salt, and as I told you, we want to make it even better, faster, and we are committed to improve Salt as much as possible, right? These are few of the things that we have contributed during this year. For example, Salt SSH support for multiple Python versions. We have done a lot of work around the Salt SSH. If you remember, before latest version of Salt, you had to create your roster file in order to start playing with Salt SSH. Now you can just Salt SSH IP and then run your modules. It will automatically create the roster file for you once you authenticate. So yeah, we are trying to make easier to start playing with Salt. It's like that, without installing minions, and so of course you can install the minion. And then we also provide this auto-discovery stuff. So in small environments, we have this feature that allows the minion to auto-discover the master. So you don't have to set any configuration in the minion. It will try to auto-discover that master, and it will connect directly. One of the new things that we have, we are working at the moment is the Salt-based Superconfig. We will show you later. And also the Salt capabilities, which is currently in the RFC state, but hopefully it will be implemented soon. So thank you all for collaborating with Salt. We want also you to take part on this. We have promoted the RFC process on Salt. So on every new feature idea, we start with an RFC, allowing community to also take part on the discussion, give us feedback, and also be involved on the upcoming features design and development. We are actually also heavily active reviewing the upstream Salt pull request. So thank you all, and we hope that you keep collaborating with Salt and with us. So the idea, I will go now with mentioning some of the main selling point of Ansible, right? And let's talk about each one of them. First thing you saw in Ansible is that they say this agentless, and that's good for immutable servers. Well, it's agentless, but it's also clueless, right? So It's like, clueless system that works like a POP3 mail system. So it's totally silent unless you explicitly click to talk with him, right? You can run monitoring on Ansible, integrate it back and to be triggered by Ansible, but then it's no longer a simple setup, okay? Keeping the analogy, POP3 is still around, but if you have a lifestyle like in the 20th century, it's okay. But if we are now in the 21st century, and as long as you are using smartphones, other devices, then POP3 is not the most efficient way. You have IMAP. So yeah, the idea is also applied to Ansible. So in Ansible, you have no agent, but you also have no clue what's going on there unless you explicitly run fetch mail like in POP3, right? Also, while Ansible talk about immutable infrastructure, you know, instead of configuration management, the idea here is that you deploy the stuff, the instance, you set it up, and once you want to do whatever on that instance, what you will do is, okay, I create another instance, I set it up, I test it, and once it's ready, I will destroy the previous one and will replace it. That's okay. The immutable concept is kind of, let's say, strange because actually the servers are not immutable. If there are database running there, the database are writing, the storage is writing, the data from customer is still mutable, so there are no perfect systems actually. And with configuration management, you can also more or less follow this approach. You can define and construct your baselines and your images, and you can manage the life cycle of them. Another selling point is about security. So Ansible runs on SSH, and SSH is just fantastic, right? Well, it's fantastic unless you find a bug. We have also the problem of a small TCP static site windows that makes also high latencies and also problems, well, high latency when transferring stuff and so on. And then we have the risk about managing the keys, right? We have to store the keys, key rotation, sharing replication, and so on. Of course, we love security. We want security, but we know that the software can be broken, and SSH can be broken too.
Did Bo do that picture?
So easy and simple. They say so. Do you remember that? Well, we all did this. I mean, it was really easy to write PHP on that time, right? Very sweet, very easy to start with. But what happened next? What happened if we scale up to billions of users? Then, like Facebook did, you have to, write everything, hip hop, convert PHP into C++, and try to do something in order to be able to grow. If not, your game is over. So why not to start it right from the beginning? That's what's happened when it grows. You have a hammer, which at the end doesn't work, okay? So yeah, SSH is fantastic, but SSH simply doesn't scale. What we also have is this, you know, this Galaxy Ansible. So it's basically a collection of modules that has been submitted from community users, right? Okay, it sounds good. But the question is, who controls the quality of that? Can you guarantee that that code is audited? Where to store those audited versions and prevent from altering it? Because, yeah, we as a enterprise, we ship RPMs, and those RPMs are signed. They have checksums, so you can ensure the code that has been not altered or whatever, right? Sorry. So, how Salt improve all that? We are going to talk not about the difference, but how we have improved the over problems on Salt. Ansible might be different. It might be more convenient at some point, but it's not necessarily overall better, especially if we are thinking in the long run. So, okay, Salt, battery include. We don't like Perl for not being battery include. We don't like also Ruby, poor quality gems. We love actually Python, which comes with many default modules with excellent quality, and Salt is also resemble this culture. If you have a bug fix or feature, you just submit pull request to upstream, and it will be only one vendor which is reviewing, merging it, and it will be part of the battery. If you got an RPM, it's vendor supported. Any change to it, you will see you will see by verifying the consistency. And if you install truly live random modules, you don't know actually what is going. Who is going to take the responsibility of that code? And we are talking here about serious enterprise. So this is not something that. This downloading live module from the internet and then playing with that is not something that an enterprise environment like. Then, okay. So how exactly Ansible is going to report the status of the machine if not even there, unless you just explicitly click to do so. So in Salt, we can handle events all around the places. It's different from monitoring. We have events that not only say, okay, true, false. We have events that give us information. And of course, we can do event-driven orchestration and all that kind of stuff, right? Okay. So as I told you, well, it's not going. Okay, now. So unless you are really small, your infrastructure is going to grow. You want it or not. Your customer data will grow, your configurations will differ, etc. So Salt is really ready for configuring complex cluster and ecosystem. The pool event bus wins here. We are ready to handle large amount of machines in heterogeneous environments, nodes that change a lot, and Salt is ready to do complex orchestrations to define also complex environment. This is something that Ansible is not able to do. Okay, but we have this, well, do you remember the hammer from before? So yeah, with Salt, you don't have that problem. You can go from the nano to the epic smoothly. But there is Ansible Tower. Yes, there is. And it actually makes a lot of, it brings you a lot of different features that Ansible, plain Ansible does not have. But here we are talking about a completely different product, right? It actually needs also, it brings you also new dependencies. You have to install Postgres, OpenShift, blah, blah, different stuff. So this is no longer simple, and this is, of course, not open source. So it remains also like a Puppet environment, where the Puppet server for managing Puppet agents is not written in Java, and it has a lot of components that you need to put together in order to get it work. So what's the future? So as I told you, SUSE is committed to contribute to Salt. We want to make it easier to start, more consistent, even faster, and even more salty. So let's take into the car, and let's take a look at the future. So the first cool thing I want to talk is this new Salt Superconfig. We already have a pull request. It's ready to be merged. It's not yet merged, but it's there. I will show you a demo now. We at SUSE have a tool which is called Superconfig, which allow us to, when a customer has some problem and they want to report a bug, they create the report, but they also run this Superconfig tool in their servers, and it will gather all information of that server, let's say, which packages are installed, if there are some packages that need upgrade, hardware information, log files, and all this kind of stuff. So the customer provides us this tarball, and it basically, it's really helpful in order to start troubleshooting. So the Salt Superconfig is basically a remake application of the SUSE Superconfig, but it's made all by Salt. We will see now the demo of that. So you can collect only what you need. So you can define your profiles. Of course, we provide multiple profiles, but you can create your own profile to collect exactly the information you want. Of course, you can actually submit your new profiles, and you can put it upstream. So we will have it included in the support config. And yeah, it examines Salt itself, but it also gathers the information of anything that is around that. So yeah, it basically will give us a complete set of logs and information from that server, which will help us to troubleshooting and to find the problems that there is. Let's go with a demo of this Salt support. As I told you, it's not yet merged, but it's going to be merged soon. Let's see, because I have to. This is going to be tricky. I have to. I have an issue with the configuration of the screen, so. Okay, let's talk about what we have here. So this is an environment I have with a Salt master and a Salt minion. I have the Salt support here included, so I can run it. So the idea is that, well, let me go to the, is the font, big enough? Right, no? Okay, so we have this new tool. Let me just put here. Okay, it replicates more or less the usual Salt syntax. The idea is that we have here some units. In this case, this is a minion. So it will collect information regardless to the minion, and we have the different profiles that are available right now. We have the default profile, network, Postgres, different. So let's say I want to run the default. Want to run the default profile. Let's run it. Let's see what's happening. Okay, so it starts collecting CPU stat, virtual memory information about the upgrades. It will take, well, it's refreshing the repository. Hopefully, it will release soon. So at the end of this process, we will have a tarball which contains all this, okay, all this information. Let's see if we can see it. Okay, there is. So and let's take a look, for example, to configuration. And what we have here, information, all the information about the configuration of the Salt minion. We have, for example, information about the general, let me just move this a bit. Okay, better. Memory information, CPU, partitions, all this kind of stuff. And as I told you, you can define your own profiles. You can call any Salt module from inside the profile for gathering the information you want, and you will just set the how you want to this information is then present. Let's take a look at one of the, this is a profile I have. It's for the network, and this is how a profile looks like. It's really YAML. So for the network profile, I want to get the host name, get FQDNs, all this kind of stuff. I want to output this information as a table or whatever. So I can actually run support. Let me remove the previous one. And I want to salt support -p, and I can even use directly with my profile. It will only run that. As simple as that. So that's the idea. We have a new tool now that is really easy to run, and it will create a tarball that you can just send to together with the bug report or with the issue that you have, and it will help a lot at the time of troubleshooting. Okay, let's go back here to the presentation. Okay. Okay, let's keep it here. Go there again. Oop. Okay, next thing is Salt capabilities. So on the enterprise environment, we have this problem very often, which is that we cannot actually trust on the Salt version in order to know if certain capability or feature is available or not on that particular minion. For example, when we have the same Salt version, it might happen that a customer reports some issue, and then we create a patch, a PTF for that, which is applied on top of the package of Salt. So that customer or that particular system, even if they are both the same version, the same Salt version, let's say 2018.3.0 or wherever, you don't actually know, or you are not really sure that this particular minion has some feature or not. Also, in case that the versions are not the same, it also happened that we have, for example, we still support SLS 11, which has Python 2.6. So we have a frozen Salt package there, and we backport functionality there. So we have a minion which is 2016.11.4, but it has also features that comes in other version of Salt. So we need somehow a mechanism which allow us to know when we are creating SLS files, state files, if that capability is there or not. Currently, we have this, is still on RFC process. There is some prototype, but we cannot show you here at the moment. I will just show you how it will look like. So no problems, that's Salt capability. This is a SLS file, and a state file, and we can do something like that. So in case that host is now a parameter of the network ping function, let's do something. For example, we implemented some time ago on the zipper module and also in the YAM module, this patch installed and patch download, for example. Instead of package install, we can reference patch names. This feature, in case that we have an SLS file for installing certain stuff, we would like to check if this feature is there or not. So we can do it with this kind of stuff. This is an SLS file. Also, we can do something like, okay, let's see if the zipper info install documentation contains reference to this particular parameter or whatever, and then we can take decision there. We can, instead of provoking that the state will fail on that minion, we can prevent us from that. Cool. Okay. SolWins, now what? So, did you finally made a choice to move to Ansible? Or do you have a system that you want to move to Salt, an Ansible system you want to move to Salt, but you have a lot of work that you have invested on Ansible. You have written modules, you have written playbooks, and so on. So it's not easy to migrate from Ansible to Salt. So here is the answer to that. SaltStack. Have you heard about SaltStack? Oh.
He's saying it with all seriousness.
So, yeah, this is already included in Salt 2018.3 codebase. And this is basically a module, and an execution and a state module that will allow you to run Ansible modules from Salt. And it will also allow you to apply playbooks, Ansible playbooks from Salt. So you can reuse all those playbooks that you invested time and effort to write, and you can reuse those when you are migrating to Salt. For example, also a problem is that on enterprise environment, there are customers that, okay, they have all those modules, playbooks, they have been audited, and now you need somehow a way to, okay, let's try to keep using that to smoothly migrate step by step to Salt. If you say, okay, you have to, all that work you have to, okay, it's not valid anymore, you have to recreate all the stuff now on Salt, it's kind of not really, a smooth migration, right? So I would like also to show a few examples of how this SaltStack works. Let's do a demo. Again, I have to, sorry about that. Again. Okay. Well, we have, oops. The minion is there. What do we have here? Ansible list. Well, I didn't tell you something. It's currently one of the requirements of the SaltStack module is that Ansible needs to be installed on the minion. Okay? So you have Ansible installed on the minion, and then you can use this Ansible gate to list all the modules that are there. You can also, let's say, filter in here, you see, you can run it. I'm going to run system ping. Let's put some data in. Oop. From Salt. Well, help from Salt. Help. Okay. So this is basically, so we are this create a Salt job that tells the minion, okay, you have to run this Ansible module. It will run the Ansible module, and we will just output the results to Salt, and you will get it like this. Not only that, we also have a state module for Ansible. Let's just show Salt. I have here my Ansible state. This is just for calling an Ansible module from inside a SLS file. As I told you, the next step, which is already in developed, is directly, you just set Ansible playbook, and you reference there the YAML file from the playbook, and you can execute the state, and it will execute the playbook for you, right? Let's try to see what happened when we try to do this. So Salt, state apply, my Ansible. Like that. Huh? You got it. Woohoo! So the idea behind Ansible is that, okay, when you are facing this situation of a customer that is running Ansible, you can say, okay, but you can migrate to Salt. You can even keep running your Ansible stuff. And you can also start playing with Salt. You can reuse your previous work. You can keep it here, but you can start doing new things around Salt. And at some point, eventually, you will get rid of all your playbook, and you will replace with Salt states and all the new stuff that comes from Salt. Yeah, that's the idea behind SaltStack, to allow customers to smoothly migrate to Salt. Okay, let's go back here. Okay, that was the last demo I have for you. So, okay. Oh, sorry, demo, the capability. I just SaltStack demo here. So next steps around this SaltStack. We would like to be able to run these Ansible modules through the SaltStack. It's not possible at the moment. We would like also to, if it's possible, to prevent installing Ansible on the client, on the minion, and be able to do something like the SaltStack does with the Salt thing. So it would be great that we could deploy Ansible there if it's not there, and we could also wipe it out once we are done with the work that we want to do that. And also, Ansible allows you to run non-Python modules. So you may have a module written in Go. So your customer has this module, and you want to also allow to run those modules from Salt. So these are few things that we have in mind for the future around the SaltStack stuff. As I told you, I didn't demo, but you can, at the moment, it's already in develop, you can directly apply playbooks using Salt. Sorry. Okay. So that's more or less what I have for you, but just one more thing. If there is Ansible Tower, you know that we have the alternative for it, which is called a SUSE Manager, right? It's based on a spacewalk. But as we announced today during the keynote, we have now a new upstream project for SUSE Manager, which is called Uni. So it will, SUSE Manager upstream projects, it provides you all the features that come from SUSE Manager, and we would like to also invite you to participate, contribute, and be part of the community, of the Uni community. We have already the source code on GitHub, and we have already a Uni channel on Freenode, so you are very welcome to join us and start being part of this new community for the Uni project. So please stay tuned. Yeah, that's basically what I have for you today. So thank you very much. So if you have any questions or something, please. Mm-hmm.
With that, you have like your profile defined, right?
Mm-hmm.
And could I take that and run something like an orchestration, and then have that gather the output of an orchestration?
Mm-hmm.
And also like or maybe rerun that. Like in my environment, it's a highly available environment, and I can't just like set debug logging in my minion and restart that or something, right? Mm-hmm.
Mm-hmm. The idea is that you can actually run whatever you want on Salt. So you define what you want to run, and the Salt support is going to execute that, and it will collect that output, and it will put it into that tarball. You can even run, well, I have not tested.
I could run any runner as well.
Exactly. You can run any runner. That's the thing. You could even run the orchestrator, and you will collect the output from that, and it will be as part of the Salt support output, and it will be included in the tarball. Yeah.
They didn't show us. Is that part of the SUSE manager?
No. The Salt support, there is already a pull request created for develop, is approved, so it's going to be merged soon, right? So.
It will be in SLS.
Sorry?
It will be available for SUSE
Yes.
Enterprise customers.
Yes. Yes. Any other question? Please, Joe?
Not really a question, but one of the things to add, the stuff you're doing with salt foods, will be Pixie foods, a salt minion into a RAM disk, and basically connect to salt master. That's really one of the things that I can't even imagine how I would ever be able to do that. Because what you would have to do is you would have to know there'll be a node coming up that is already preceded with the right SSH key, and I need to somewhat magically find out that it exists now and then actively connect to it. With salt, we can really do that fully event-based because that thing will just call home. It will come up. It will say, I'm here now. What should I do next? And we can then auto-accept it based on those claims that we now have with the great whitelisting. And we can have fully automated client-initiated workflows that we can never even imagine how to build that in a I'm sure there are many more, like using it more in the monitoring way, and trying to find out how to just run some stuff that Ansible does do. And I'm really curious why people start using Ansible for, let's say, network automation, when the network you choose, you want to communicate with it. You don't want to just fire jobs and hope that the output is something else will run the next job.
Over there. Well, it should run. It's pure salt, actually. So if you can just define. So the question was if salt support runs on Windows. So if salt runs on Windows, you can define your profile there, and you can just execute those salt calls.
But don't use it to try to get SUSE to help you.
Okay. Any other question? Over there.
What's the right question to ask Ansible to test their ability to salt? In other words, how does salt beat Ansible in a head-to-head competition?
So I'm not really sure. Could you repeat the question, please? Rephrase it.
What question do you ask Ansible that will expose their shortcomings or shortfall in comparison to salt? What's the test or challenge that Ansible can actually meet?
I'm not sure. Do you have an answer for that?
So what I already mentioned, I mean, anything that has to do with net-based, with client calling in, can't do with Ansible. The other thing that we are hearing a lot is that it just is so slow that you deal with a lot of losses. I mean, it's reliable. The SSH is kind of simple to set up, yeah, but it can take a long time, especially if you run it in parallel. And then, of course, orchestration all has to happen on the while in a salt run, you could do during the run, with events that make sense of that.
Thank you. Any other thing? No? Then thank you very much. Yeah.